there, my name is Dr. Marissa May. In this video, we'll be covering some of the triangle basics. Now you can see the term triangle is a plane closed figure formed by three segments joining three non-collinear points. Most of us are familiar with what a triangle might look like, with three line segments being connected. And this triangle is made up of three components: the vertices, which in the picture at the bottom would be P, Q, and R. Those are the points or the corners of each of the sides of the triangle. And those sides would be line segment PQ, QR, and PR. Also, there are three angles in a triangle. In this triangle, there's angle P, angle Q, and angle R. Now, we can classify triangles by the lengths of their sides. So a scalene triangle would be a triangle that has no congruent sides. So all three of the sides are different lengths. Now, an isosceles triangle is where two sides are the same. And an equilateral would be where all three sides are the same. So if we look at the examples at the bottom, you see A is showing you with these little dashes on the sides that all three of those are the same. So A here is an equilateral because all three sides are the same. B is showing you that because this one has one dash and this side has two and this side has three, that's showing you that none of the sides are the same. So we would call this a scalene triangle. Then C is showing you that these two sides are the same, but the third is not, and this is where we get isosceles. So three different ways to classify angles based on the length of their sides. Now, one important detail about all triangles is that the sum of the measures of the interior angles must add to 180 degrees. So because of these angles inside of a triangle, we can also classify the triangles by their angles. So a triangle is said to be acute if all three of the angles are acute. And acute means that all three of those angles are less than 90 degrees. Okay. An obtuse angle is a triangle in which one angle is greater than 90 degrees. So you might have an angle that's bigger than 90 degrees, and it looks something like that. And this would be called an obtuse triangle. Now, a right triangle is one in which one angle has exactly 90 degrees. And so here's a 90-degree angle, and we have the triangle made out of it. That little square in the corner there is used to represent a right triangle. So let's recap. You can classify triangles by their sides or by their angles. So let's classify these triangles. For A here, I want you to see that all three angles are the same and all three are less than 90. That makes this an acute triangle, B here, all three angles are less than 90 degrees. Again, we could call that acute. C, we have the one angle here that's bigger than 90, and that makes this triangle obtuse. And then D, notice we have the right angle right there, and so this is a right triangle. Let's take a look at example 3. Find the measure of the third angle of a triangle if the first measure has a measure of 66 and the second angle has a measure of 37. Now, I'm a visual person, so I like to draw. So I just go ahead and label these. This is a 66 degrees, 37 degrees, and you'll remember that all three have to add to 180. So what I'm going to do is I'm going to add the two I know. 66 plus 37 will give me 103. And then I'm going to subtract that from the 180, and I'll get 77. So that third angle is 77 because I know all three angles added together have to give me 180 degrees. Next, let's take a look at similar triangles. So when polygons or triangles are similar, you have two conditions. First of all, corresponding angles are equal. So the angles must be equal, and corresponding sides are proportional. So if you don't know the measure of all the sides and angles, is there another way to tell? Yes. And so we're going to talk about a few theorems that help us. Now, the first one is AA, and those A's stand for angle, angle. And this one says, if two angles of one triangle are equal to two angles of another triangle, then the triangles are not equal, but similar. So if you know that two angles are equal to each other in separate triangles, then you can show that the two triangles are similar. Basically, one is a smaller version of the other one. Think of it being like shrunk down. And that's what we get when you are similar. So can these triangles be proven similar by angle, angle? Do we have two angles that are congruent? So if we look at A, I see that I've got congruent angles with those right angles. And then I've got these angles right here that are congruent. So I do have, I've got two pairs of angles that are congruent. So that's a yes. So we see triangle ACE, that's the top triangle, is congruent to DBE. Did you notice how I put them in order? So I did the one that was pointed, A and D both came first. Then I did the right angle, C and E. And then I had the E by itself. Okay. Now, if we look at B, you see these arrows here. They represent parallel lines. And last week, in one of my previous lectures, we talked about parallel lines cut by a transversal. And so I know that this angle is congruent or equal to this angle because of those parallel lines cut by a transversal. I also know that these angles around H are also equal because those are vertical angles. So now I have angle, angle. So again, I can say yes. And let's see if we can name this triangle based on the similarity. So K, J, H. And then I'm going to have to go G, F, H. And again, I have to put them in order as to the corresponding with the similarity part. All right, our second way to show that triangles are similar is by the SAS, and that stands for side, angle, side. And it has to be in that order. So if two triangles, if a pair of corresponding angles is equal, and the sides, including the angle, are proportional, then the triangles are similar. So I want you to see that it has to be side, angle between, side. So let's take a look. Okay, we've got the angle. We're good here. On this one, we're trying to show, is it similar by side, angle, side? And then I need to go from 4 to 6. So I'm going from here to here. Is that the same as 6 to 9? From here to this side. Okay. And so what I like to do here is just a little cross multiplying. So I do 4 times 9, which gives me 36. And I do 6 times 6, which gives me 36, and it works. That's when I know that they're proportional. So I say yes here, and let's name it. I'm going to go MNL is similar to PRQ. All right. So remember, with side, angle, side, you need the sides to be proportional and the angle between the two sides to be congruent. All right, let's look at one more. Our last one is SSS, and this stands for, you guessed it, side, side, side. If all three pairs of corresponding sides of two triangles are proportional, then the two triangles are similar. And so what we're going to do here is just check and make sure, what do I need to multiply by 3 to get 9? Well, that would be 3, right? And then what do I multiply 4 by to get 12? That would be 3 also. And then what do we multiply 5 by to get 15? That would be 3 also. So these are proportional. In fact, they have a scale factor of 3. You noticed every time I took a side, I would multiply by 3 to get the other one. So let's name these two triangles. So I've got TSU is similar to WXV. Right? And so with side, 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 you're looking for are all three of the sides proportional. Let's wrap up with the Pythagorean theorem. Now, when two of the three sides of a right triangle are known, we can find the third side by using the Pythagorean theorem. So let's label our triangle here in the bottom. Notice that the side that is opposite the right angle, that is called the hypotenuse. The other two sides are called legs. And so you can see that what our Pythagorean theorem says is that if you square the legs and add them together, you should get the same as when you square the hypotenuse. What you probably are most familiar with is most people will let a leg be A, the other leg be B, and the hypotenuse be C. And they then remember A squared plus B squared equals C squared. That's the more popular form of the Pythagorean theorem. But remember, C has to be the hypotenuse. So let's take a look at an example. So in example 1, we're just going to find the value of x. And I want you to notice that x is actually the hypotenuse. So we're going to use A squared plus B squared equals C squared. And I'm going to let A be 3. I'm going to let B be 7. And then I'm going to let X be C. So in place of A, I'm going to put a 3. In place of B, I'm going to put a 7. And in place of C, I'm going to put an X. All right. Now, order of operations tells us we have to do those exponents first. So 3 to the second is not 6. 3 to the second means 3 times 3, which gives me 9. 7 to the second is not 14. It means 7 times 7, which is 49. Now we can add. So 9 plus 49 gives me 58. So 58 equals x to the second. Now remember, we don't want x to the second. We want x. And this is where we're going to take the square root. So the x is the square root of 58. Now you can put square root of 58 in your calculator. You'll get 7 point something. Okay. But I want you to see how you set up with the Pythagorean theorem. Let's do one more. Example 2 says, find the length of the diagonal of a square with a perimeter of 24. So we're looking for this diagonal right here. I'm going to call it C because it's going to be opposite a right angle. Now the key is when we know the perimeter of a square has 4 sides, all sides are the same. So if the perimeter, the distance around it, is 24, then each side had to be 6. Now we'll take one triangle, we'll let a 6 be A, we'll let a 6 be B, and we'll set up our Pythagorean theorem. So in place of A, I put a 6. In place of B, I put a 6. All right, 6 to the second is not 12, it's 36. And so now we can add them. 36 plus 36 gives me 72. And then don't forget, we don't want C to the second, we want C. So we take the square root of 72. And you'll get 8 something. All right. So I hope that helps. We did a lot of vocabulary with the triangles, classifying them by their sides, by their angles, making sure that all the angles add up to 180 degrees. Then we talked about how to tell if triangles are proportional or similar. And then we wrapped it up with the Pythagorean theorem. You've got a lot to look at here, friends. I encourage you to practice with these concepts so that you will become more familiar with the vocabulary, but also understand the logistics of how we put things into the formulas. All right. I hope this helps, and I hope you have a great week. Bye for now.